Hello everyone, welcome to Malaysia Online Tuition YouTube channel. In this video, we are going to be looking at A-Level Pure Mathematics 3, Differential Equation Review Part 1. If you like and enjoy watching this video, then please give us a thumbs up. If you want to receive updates on our newest video, then please hit the subscribe button as well as the notification bell so that you won't miss any of our future videos. Right before we start, I would like to mention that we also offer private tuition, online private tuition for Mathematics 9709, Physics 9702, Chemistry 9701, and also Biology 9700. Okay, so for question number 1, find the particular solution of the differential equation that satisfies the given condition. For part 1, dy dx equals x squared y plus y over x squared minus 1, where y equals 2 when x equals 2. For part 1, first thing first, we can see that the right hand side, we can take out the y. So we have y open bracket x squared plus 1 over x squared minus 1. So our dx will go to the right hand side. So everything involving y must go to the left hand side. So we can shift the y to the left hand side. So we will have integration of 1 over y dy equals integration of x squared plus 1 over x squared minus 1 dx. Okay. So on the right hand side here, we have x squared plus 1 over x squared minus 1. So this is improper algebraic fraction. So what we can do here is we can first, what do we say? Long division. Okay, do long division so that it is becoming a proper algebraic fraction. So we do long division. So x squared plus 1. So actually we have to write x squared plus 0x plus 1. Okay. Divided by x squared minus 1. So we have 1 here minus x squared over here and then minus 1. So 1 minus negative 1, that is 2. So now we have this to be 1 plus 2 over x squared minus 1. Okay. So realize that 2 over x squared minus 1 is actually a partial fraction. Okay, so how do we know that? Because our x squared minus 1, we can actually factorize that as, okay, we can write 1 plus 2 over x plus 1 and then x minus 1. Okay, like that. dx. So now you can see that we have a partial fraction to be done. Okay, so this is going to be quite a long question, all right? So now for this, 2 over x plus 1, x minus 1. Okay, so this is two linear factors. So we have a over x plus 1 plus b over x minus 1. Okay, so then you bring the denominators on the left hand side to the right hand side. So you have 2 equals a open bracket x minus 1 plus b open bracket x plus 1. Okay, so we can use the elimination method, and for example, when x equals 1, we have 2 equals, okay, so a is eliminated because 1 minus 1 is 0, so we have 2b. So our b is 1. So then when our x is negative 1, so that we can eliminate b, 2 equals negative 1 minus 1, that is negative 2, so negative 2a. So our a is negative 1. So finally, the partial fraction is going to be negative 1 over x plus 1 plus 1 over x minus 1. Okay, so we can continue the integration over here. So on the left hand side, 1 over y dy, right? The integration is going to be ln y equals integration 1 minus 1 over x plus 1 and then plus 1 over x minus 1 dx. Okay, so then we can integrate the right hand side. So integration of 1, we get x minus integration of 1 over x plus 1, that is going to be ln of x plus 1, because when you differentiate the denominators, which is x plus 1, you get 1. And you already have 1 on top, so it is straight away ln of x plus 1. The same reason we are going to use for the 1 over x minus 1. So this is just ln of x minus 1 plus c. That's it. Okay. So then we can straight away substitute when x is 2, y is 2, because we want to find the constant c there. Okay. So ln 2 equals 2 minus ln 3 plus 2 minus 1 is 1. So ln 1, and you know that ln 1 is going to be 0. So we can say that this is 0. Okay. So then what is our c? Ln 2 plus ln 3 minus 2. Okay, so what is this? Ln 3 and plus ln 2 is going to be ln 6. So ln 6 minus 2. Done. Okay, so now for the conclusion, okay, meaning they said we need to find a particular solution, right? So for the particular solution, they didn't mention anything about leaving the answer like y in terms of x and so on. So you can just leave the answer like this. So ln y equals x minus ln of x plus 1, and then plus ln of x minus 1, and then plus ln 6 minus 2. Okay, so this is the particular solution for this differential equation. Okay, so that's all for question part 1. Okay, so now moving on to part 2. We can cut it here. Okay, so for part 2, we have cos squared x and then dy over dx equals xy squared. Okay, and then given y equals 2 when x equals 0. Okay, so we can see that our dx will go to the right hand side. So anything involving x must go to the right hand side. So our y squared will go to the left hand side. Okay, so what do we have here? We have integration of 1 over y squared dy equals integration of x over cos squared x, and then we have dx. Okay, so for the left hand side, what we can do is we can bring up the y squared so that it becomes y negative 2. Okay, y power of negative 2 dy, and then on the right hand side you can see x over cos squared x is actually integration of x secant squared x dx. Okay, so on the right hand side here we have integration by parts, okay, because we have two functions which are multiplied. Okay, so now we can say that u equals x and dv equals secant squared x dx. Okay, so the reason why we are taking our u as x and our dv is secant squared x, because we are using the late method. Okay, late here stands for log, and then algebra, and then trigo, and then exponential. So whichever is more above, okay, it's going to be the differentiation. So you can see algebra, which is our x, is above the trigo, which is secant squared x dx. That's why we are using u as x and dv as secant squared x dx. So du equals dx, and then the integration of secant squared x dx is going to be tan x. Okay, you can refer to MF19 for this integration. Okay, so then the integration is going to be like this. Integration of x secant squared x dx, meaning that later we can just substitute this inside the differential equation. Okay, so the formula is going to be uv, so that is going to be x tan x minus integration v du, so tan x dx. Okay, so how to integrate tan x? Okay, so this is a basic integration. So x tan x minus, okay, so this is integration of sine x over cos x. Okay, so we know that the differentiation of cos x is negative sine x, but since we don't have negative sine x on top, we have sine x only, we can take out the negative, so we will have plus outside. Integration negative sine x over cos x dx. Okay, so now we can use the ln, okay, the integration that will give us ln. So x tan x plus ln cos x, okay, and then plus c. No, plus c later, okay? We will do it later. Okay, over here. So the left-hand side, our integration is going to be y to the power of negative 1 divided by negative 1 equals x tan x plus ln cos x plus c. So before we substitute the y equals to x equals 0, this is negative 1 over y equals x tan x plus ln cos x and then plus c. Okay, so now we can substitute the limits. So when x equals 0, your y equals 2. Okay, so then we can write negative 1 over 2 equals 0 plus cos 0, remember, okay, cos 0 is not 0, cos 0 is 1. So 0 plus ln 1, which is actually 0 as well, plus c. So your c is negative 1 over 2. Again, the question doesn't say about giving the answer in y in terms of x or x in terms of y, so you can just leave your answer like this. Negative 1 over y equals x tan x plus ln of cos x and then minus 1 over 2. Okay, so this is the final answer for part 2. Let's continue with question number 1, but now part 3. Cos y dy dx, okay, and then we have equals x squared cosecant squared y. Okay, so we can see that dy is on the left, so dx must go to the right. Okay, dy is on top on the left. So everything involving x must stay on the right. So cosecant squared y, we need to shift this to the left. Okay, so then what do we have? Integration of cos y over cosecant squared y, don't forget dy, equals integration of x squared dx. Okay, so we know that cosecant squared y, okay, is going to be 1 over sine squared y. So what we have right now is going to be cos y sine squared y dy equals integration of x squared dx. Okay, so the question now is, how do we integrate cos y sine squared y? Okay, the method to integrate this, okay, is actually using the integration by substitution. So what are we going to do? Okay, so I'm using red color for this one. So for this one, we are going to substitute u equals sine y, and then our du equals cos y dy. So as you can see, cos y dy will change into du. Okay, so we will have u squared du, like that. So the integration is going to be u cubed over 3, okay, plus c, but we will put the c on the right hand side. So this is just sine cube y over 3 plus c, okay? So now we can continue the integration. So we already know that the integration is going to be sine cube y over 3, okay, equals, this is going to be x cubed over 3 plus c. Okay, so since we can see that on the left and on the right hand side we have over 3, right? So we can just straight away multiply everything by 3. So we get sine cube y equals x cubed plus a. Okay, so why do we write a? Because a constant multiplied by 3 will just be another new constant. So we can just use another letter, for example, a. So now we can substitute the conditions. Okay, so when x equals 1 over 2, your y is pi over 2. Okay, so we have on the left hand side sine cube pi over 2 equals 1 over 2 cube plus a. So what is this? Sine pi over 2 is 1. So 1 to the power of anything is just going to be 1. So on the left we have 1 equals 1 over 8 plus a. So finally our a is 1 minus 1 over 8, and that is 7 over 8. And the conclusion, okay? So the answer is going to be sine cube y equals x cubed plus 7 over 8. So this is the final answer for part 3. And for part 4, okay, we have e to the power of negative x squared dy over dx equals x open bracket y plus 2 close bracket squared. Okay, as usual, separate the variables first. So our x is going to go to the right hand side, and then our y plus 2, okay, bracket squared is going to go to the left hand side, and our e to the power of negative x squared to the right hand side as well. So we will have integration 1 over open bracket y plus 2 close bracket squared dy equals, we have integration of x over e to the power of negative x squared dx. Okay, like this. So then for the left hand side, we can bring the bracket up. So we have y plus 2, okay, bracket negative 2 dy equals, on the right we have x e to the power of x squared. So why is it like this? Because our power is a negative. Negative power means that you have to turn it upside down. So if it is on top, it will go to the bottom. So if it is at the bottom, it will go to the top. Okay, that's why this is the thing that we are going to integrate later. So if we look at the power of this exponential function, x squared. So if you differentiate x squared, you will get 2x. Okay, but don't worry about the 2. What is important here is that we get x. Okay, so this involves integration by substitution again. Okay, similar to part 3 just now. So u equals x squared. Your du equals 2x dx. But since you only have x dx, you bring the 2 to the left hand side, you get du over 2 equals x dx. Okay, so then the integration is going to be, okay, this one is going to be integration, so e to the power of u and then du over 2. So you can put the 1 over 2 outside, so integration of e to the power of u du. So what is this integration? 1 over 2 e to the power of u plus c. So u is x squared, so we get 1 over 2 e to the power of x squared plus c. That's it. Okay, so now we can put this integration in the differential equation. So we get 1 over 2 e to the power of x squared plus c on the right hand side. And on the left, what do we have? To the power of negative 1, right? So y plus 2 to the power of negative 1 divided by negative 1. Okay. So then on the left hand side, we get negative 1 over y plus 2 equals 1 over 2 e to the power of x squared plus c. Now we can substitute the conditions, okay, or the limits. When x equals 1 over 2, our y equals 2. So then negative 1 over 2 plus 2 is 4, so negative 1 over 4 equals 1 over 2 e to the power of x squared. So 1 over 2 squared, that is 1 over 4 plus c. So your c is going to be negative 1 over 4 minus 1 over 2 e to the power of 1 over 4. Okay, so finally, the final answer, okay, or the particular solution for this differential equation is going to be negative 1 over y plus 2 equals 1 over 2 e to the power of x squared, and then minus 1 over 4, okay, minus 1 over 2 e to the power of 1 over 4. So this is the final answer for question number 1, part 4. Next, for question number 2, in a certain bacterial culture, the rate of increase is proportional to the number of bacteria present. For part A, if the number double in 3 hours, find the hourly growth rate. For part A, we can say that bacteria here, we can say as B. Okay, so B is bacteria. So they said the rate of increase, that means dB over dt, is proportional to the number of bacteria present. So we can say B. So when we change the proportionality sign into equal sign, we will have a constant. So we can say KB. All right. So then what we can do next, we can separate the variables. So B goes to the left and dt goes to the right. So we have integration of 1 over B dB equals integration of K dt. So the left hand side, ln B is the answer for the integration, equals KT plus C. Okay, so what they said here, if the number double in 3 hours, find the hourly growth rate. They are asking us for the hourly growth rate. Okay, so what does it mean by this? Okay, double in 3 hours. So when t equals 3, okay, meaning the t is in hours, right? Our b is 2b not, okay, something like that. Okay, because they said the number double from the initial number. Okay, so we can say that ln 2b 0, okay, or to be not, sorry, to be not, equals 3k plus c. So then we can see that we don't have c yet, right? So we can say that when t equals 0, our value of b is the initial, which is b naught. So we can say ln b naught equals c. Like that. Okay, so supposedly we do that first and then we do the t equals 3. Okay, but it's fine. So now we can say that ln 2b naught equals 3k plus ln b naught. Okay, so we can bring this to the left hand side. So we get ln 2b naught minus ln b naught equals 3k. So this is going to be divided. So 2b naught divided by b naught. Okay, so we can cancel that. Equals 3k. So k is going to be 1 over 3 ln 2. So then our k is, okay, I think we can find the value. Forgot to open the calculator. So 1 over 3 ln 2. So that is 0.231. Okay, so this is the hourly growth rate, 0.231. Okay, because they said find, if the number double in 3 hours, find the hourly growth rate. This is the one. K equals 0.231. So that's all for question number 2, part A. For part B, how many bacteria are there after 9 hours if the original population is 10 to the power of 4? So we can say now the B naught is 10 to the power of 4. So after 9 hours, so we can say when T equals 9, so we can say ln of B equals, okay, because we want the B, right? Okay, our K is that value. So we can say, okay, because the original one is KT, right? So 0.231 times 9 plus ln B naught, meaning ln 10 to the power of 4. So then ln B equals what? Okay, we can just add that straight away. So this one times 9 plus ln of 1 exponent 4. So 11.290. So then B is e to the power of 11.290. So the number of bacteria after 9 hours is 80,000. Okay. Or you can also write 8 times 10 to the power of 4. 1, 2, 3, 4. Yep. So this is the final answer for question number 2, part B. And finally for part C, after how many hours are there 4 times 10 to the power of 4 bacteria? So we can say B equals 4 times 10 to the power of 4. So ln of 4 times 10 to the power of 4 equals 0.231 T, okay, and then plus ln of 10 to the power of 4. So 0.231 T equals ln of 4 times 10 to the power of 4. So since you know that we are shifting this to the other side, right, to the left-hand side, that means it's going to be minus. So minus meaning we are going to divide. Okay, 1 times 10 to the power of 4. So 0.231 T equals what? So this one, 4 exponent 4 divide 1 exponent 4. So we get 4 ln 4, and then we get 1.386. So T equals 1.386 divided by 0.231. We get 6 hours. Okay, so this is the final answer for question number 2, part C. Now for question number 3, a body whose temperature is 180 degrees Celsius is cooled by immersing in a liquid at 60 degrees Celsius. In 1 minute, the temperature of the body has fallen to 120 degrees Celsius. How long will it take for the temperature of the body to fall to 90 degrees Celsius? Okay, the problem with this question is, okay, they didn't mention anything about the change in temperature, okay, the D temperature over dt. So we can start this question by writing the capital T as the temperature of body. Okay, even though we start with 180 degrees Celsius, but we can just say the capital T is temperature of body. Okay, so what we need to start with, D temperature over dt is actually proportional to, meaning that the rate of cooling, okay, is actually proportional to the difference in the temperature of the body and the immersing liquid. Okay, the liquid that is immersed in. Okay, so we can say the temperature of the body, okay, we don't say 180, we just say it is T. Minus the immersing liquid, okay, is 60 degrees Celsius. So we just write T minus 60. This is how you start with the rate of change of the temperature, or we can say rate of cooling. Okay, so then changing the proportionality sign into an equal sign, D temperature over dt equals K, and then open bracket T minus 60. So you have the option of putting the negative here, or if you forgot, let's say, okay, you forgot to put a negative here, it's fine. The K will follow you later. Okay, so why is it negative? The reason is because our temperature is decreasing. Okay, you can see the keyword here, they said cool. Okay, so now we can start the differential equation solving by separating the variables. So the T minus 60 will go to the left hand side, and then the dt to the right hand side. So we have integration of 1 over T minus 60 D temperature equals integration of negative K dt. Okay, I call the capital T temperature. Okay, so on the left hand side, the integration is going to be ln of T, okay, temperature minus 60 degrees equals negative KT plus C. All right. So the first condition we already know. When time equals 0, our temperature is 180. Okay, so that's how we get the value of C. Ln 180 minus 60, that is 120, equals C. Done. And then we are also given that when T equals 1, right? Okay, because they said in 1 minute, the temperature of the body has fallen to 120 degrees Celsius. So we can say the capital T is 120 degrees Celsius. So 120 minus 60, that is 60. So ln 60 equals negative K and then plus ln 120. Okay. So we can shift the negative K to the left hand side and then 60, ln 60 to the right hand side. So K is ln 120 minus ln 60. So remember, when we have subtraction, meaning they are divided, the inside is divided. So 120 divided by 60, that is 2. So don't forget, it is ln 2, not 2, okay? Ln 2 for the value of K. So now we have the complete solution, okay? The particular solution of the differential equation. We can write ln of T minus 60 equals negative T ln 2 plus ln 180. No, ln 120. Okay. So now what we are looking for is how long will it take for the temperature of the body to fall to 90 degrees Celsius. Okay, so we can write when temperature equals 90 degrees Celsius. So on the left hand side, 90 minus 60, that is 30. So ln 30 equals negative T ln 2 plus ln 120. Okay. We shift the negative T ln 2 to the left hand side and the ln 30 to the right hand side. So we have T ln 2 equals ln 120 minus ln 30. And we know that that is going to be ln 4, right? So we have T ln 2 equals ln 4. So T equals, okay, so you know that ln 4 is actually ln 2 squared. Okay, divide by ln 2. So you shift this in front. You get 2 ln 2 divided by ln 2. So you cancel this. Your time is going to be 2 minutes. Okay. So how long will it take for the temperature of the body to fall to 90 degrees Celsius? The answer is 2 minutes. Okay. And that's all for question number 3. Moving on to question number 4, radium decomposes at a rate which is proportional to the amount present at any time. If 10% decomposes in 200 years, what percentage of the original amount of radium will remain after 1000 years? So first thing first, we can say X, okay, for example, represents the amount of radium present, okay, meaning not the amount that decomposes, the amount remaining, okay, the amount present. So they said the radium decomposes at a rate, okay, so we can say dx over dt is proportional to the amount present at any time. So we can say x, okay? And then as usual, when we change this proportionality sign into an equal sign, we have kx, okay? And then as usual, you bring the x to the left-hand side and then dt to the right-hand side. And then what do we have? Okay, so like I said, for this one, right, if you forgot to write negative in front, okay, if this is decreasing, okay, because you know that this is decreasing, right, because they said decomposes. Okay, but let's say you forgot to put negative. You will still get it correct because your k is going to follow whether you put a negative or not in front, okay? So now we will have integration of 1 over x dx equals integration of negative, let's say I didn't put negative in front, okay? Integration of k dt. So then on the left, we have ln x. On the right, we have kt plus c. So they didn't give us any amount of radium, initial amount of radium. So we have to say that when time equals 0, or we can say in the beginning, the amount of radium that we have is x naught, okay, or the initial amount. So then we can say ln x naught equals c. That's it. And then they said after 200 years, right? When t equals 200, 10% decomposes, meaning how much do you have left? 0.9, okay, or 90% left. That's why we write 0.9 x naught. So we have ln of 0.9 x naught equals 200k plus ln x naught. So now what we can do is we can find the value of k. So ln of 0.9 x naught minus ln of x naught equals 200k. Now you know this is going to be ln of 0.9 x naught over x naught, and then you can cancel that, equals 200k. So what is the value of your k? Ln 0.9 over 200. Okay, so you can leave it like this, or you can change it into decimal values if you want. Okay, for this question, I will just leave it like that. And then finally, we have our differential equation solution as ln x equals ln 0.9 over 200 T plus ln x naught. Okay, done. So what they are asking for right now, what percentage of the original amount of radium will remain after 1000 years? So now we can say that when T equals 1000. Okay, and please be careful of this. They said percentage of the original amount of radium. So when they say that, what you need to do is you need to get x over x naught. Okay, x over x naught, meaning the present amount over the original amount. Okay, so this is what we are looking for later. So now we have ln x. Okay, so we can shift the ln x naught to the left hand side straight away. So minus ln x naught. Okay, ln x minus ln x naught equals ln of 0.9 over 200 times 1000. And then you can see this is going to be ln of x over x naught. And you can see that inside the bracket here is what we are looking for. So this is going to be 1000 divided by 200. That is going to be 5. So 5 ln 0.9. So then x over x naught. Okay, you bring the base e to the right hand side. X over x naught equals e to the power of 5 ln of 0.9. So what's the answer? We are going to get decimals, okay? But we just have to multiply by 100 to get the percentage, okay? Shouldn't be a problem. So e to the power of 5 ln 0.9. So we get 0.590. So when you multiply this by 100, you will get 59%, okay, of the original amount of radium will remain after 1000 years. So this is the final answer for question number 4. Finally, we have reached the final question of this video, which is question number 5. A tank contains 40 gallons of a solution composing of 90% water and 10% alcohol. A second solution containing half water and half alcohol is added to the tank at a rate of 4 gallons per minute. At the same time, the tank is being drained at a rate of 4 gallons per minute. Assuming that the solution is stirred constantly, how much alcohol will be in the tank after 10 minutes? Okay, and the answer later that we need to get is 14.1 gallons. So for the start of this question, X is going to be the amount of alcohol present in the tank. Okay, so what we need to find first is dx over dt. So realize that at the same time that alcohol is going out of the tank, okay, the reason why is that you can see the tank is being drained at the rate of 4 gallons per minute. So we know that in the tank we have 40 gallons of the solution and 90% of it is water and another 10% is alcohol. So we have the alcohol to be going out of the tank. And at the same time, alcohol is being added to the tank through the second solution here, okay, at the rate of 4 gallons per minute as well. So you have alcohol going out of the tank and you have at the same time alcohol going into the tank. So the thing is, the amount of alcohol going into the tank is fixed because they said half alcohol and then they said at the rate of 4 gallons per minute. So we know that the amount of alcohol added to the tank is 2 gallons per minute. So you can say 2, a fixed 2, okay, just like that. And then at the same time, the tank is being drained at the rate of 4 gallons per minute. And we know that 10% of that is alcohol. But if you want to know how much alcohol is leaving at a certain time, you have to look at the rate at which the tank is being drained. 4 gallons out of the 40 gallons that you have. So 4 divided by 40, that is 0.1. Okay, so you can write minus 4 over 40 and then times the amount of alcohol present at any time, which is x. So that means your dx over dt is going to be 2 minus 0.1 x. Okay, so this is how you start your working solution, by getting the correct dx over dt. So now we can separate the variables. So 2 minus 0.1 x, okay, altogether we are going to shift this to the left hand side, and on the right we will have dt only, okay, integration dt. So 1 over 2 minus 0.1 x dx equals integration dt. Okay, so on the left you can see that the differentiation of the denominators is going to give us negative 0.1, but we don't have negative 0.1 on top. So that's why we need to modify. So we get negative 0.1 on top. So in order to do that, we need to take out negative 10. Okay, and how do we know this is true? When negative 10 multiply with negative 0.1, you will get again the 1 that we have on top originally. Okay, equals to t plus c on the right hand side. So this is going to be negative 10 ln of 2 minus 0.1 x. equals T plus C. Okay, done. So now we can see that how much alcohol will be in the tank after 10 minutes, okay? We don't know that. But what we know is when T equals 0, meaning initially, how much alcohol do we have? 10%, okay, of the 40 gallons, okay? But we can just say when T equals 0, okay, what is our X? 4 gallons, okay, 4 gal. So we can write negative 10 ln of 2 minus 0.1 times 4 is 0.4. 2 minus 0.4 is 1.6, okay? Negative 10 ln of 1.6 equals C. So your C is negative 10 ln 1.6. Okay, you can just leave it like this. No need to write the decimal answer. Next, we have the negative 10 ln of 2 minus 0.1x equals T plus C. So what we can do now is we can make x as the subject. Okay, I forgot to change this. Minus 10 ln 1.6. We shift this to the left-hand side. And then what we have is 10 ln 1.6 minus 10 ln of 2 minus 0.1x equals T. So we can take out the 10. And then we will have ln of 1.6. And then you can see that since you have minus, that is going to be divided. So 1.6 over 2 minus 0.1x equals T. And then you can shift the 10 to the right-hand side. So T over 10 is going to be 0.1 T. At the same time, you will have ln of 1.6 over 2 minus 0.1x. So you shift the base e to the right-hand side. So you will have 1.6 over 2 minus 0.1x equals e to the power of 0.1 T. And then you bring this to the... Oh no, you don't bring that, okay? You swap them. So you will have 1.6 e to the power of negative 0.1 T. Okay, so why negative? Because your exponential function here is going to go down or below the 1.6. So if you want to bring it up, you are going to put a negative to the power. That's how we ended up with 1.6 e to the power of negative 0.1 T. So next, what do we do? Equals 2 minus 0.1x. Okay, like this. And then 0.1x equals what? This is 2 minus 1.6 e to the power of negative 0.1 T, like this. And then x equals 20 minus 16 e to the power of negative 0.1 T, okay? Something like this. Okay. Now what we are going to do is we are going to replace our T with 10 because they said after 10 minutes. So we can write when T equals 10, x equals 20 minus 16 e to the power of negative 0.1 times 10 is negative 1, okay? So let's calculate this and see whether we get 14.1 gallons or not. So 20 minus 16 shift, okay? E to the power of negative 1. So you can see the answer is 14.1 gallons, okay? So we get the answer to be the same with the one that I wrote in the beginning, okay? So that's all for this question number 5, and that's all for this video about differential equation review part 1. So if you have any question or any comment, please leave them in the comment section below. So if you like and enjoyed watching this video, then please give us a thumbs up. If you want to receive updates on our newest video, then please hit the subscribe button as well as the notification bell so that you won't miss any of our future videos. Thank you very much for watching this video, and finally, please take care, and I hope to see you in our future videos.